green wire to the side of the machine through a little ground lug. This is the ground wire coming in from the disconnect. You can see the green over here. Green to green goes into the unit. Green in the electrical world denotes a ground, right? Or green with a yellow stripe. Or what? Bare naked wire. It don't have to be ground. It don't have to be green. It could be bare copper. But it has to be bolted some way to the side of the metal chassis, the outside of the unit, to connect the wire to the unit machine, right? The outside of the machine. It's real easy. You just put the bare wire under that hole, that lug, and you tighten the screw head down on it real good and it's tight.
Make it good. 11 and 1. That's the 11 and 1 you got?
Yeah, it's just a flathead right there. It's a flathead screw right there. You just stick the slotted screw in there, called a flathead, and tighten it down good and firm. And that wire is connected to the metal to metal, right? So the machine is grounded now. If any electricity got on the bare body of the machine, it's going to flow through the ground wire back to here, and get on this ground wire, go back to the circuit in the building. All the ground wires in the building are all connected together. But they ultimately go somewhere in the ground out there in the earth, some Mother Earth ground. A rod, a metal rod is connected into the earth somewhere. And it's connected to all green, bare, naked wires running around the building, ground wires, okay? This is the compressor contactor. It's like that relay I was telling you about. It's got two little wires on the side that are the 24-volt control voltage, and they connect to the side of the unit. That brings the 24-volt common, 24 to each side of the coil. When it energizes, it's going to snap the switch closed. Then this L1, L2 here is each 120 volt apiece. They're going to flow through the switch and into this motor and to the compressor. That motor and the compressor on each leg. And that's going to happen because we energize the 24 volt coil connected to the side. And that stays connected all the time. I just pulled it loose to show you how easy it is to disconnect. But when that thermostat sends the signal out here and wants the condenser to air to run, it's going to energize the coil on the side with 24 volts, pull the switch in, then the motors get their power to operate. The 240 flows in, right? Controlled by the 24 volt through the relay, right? This is a run capacitor. This is a split run capacitor. 3 terminals. The common to Herm goes to the compressor. Common to fan goes to the condenser fan motor. This one capacitor run works with this motor and the compressor inside, right? This one is fairly simple. There's no start capacitor, no start relay or anything in here. This is more common in your average run-of-the-mill air conditioning system out there that is two-position on and off. Most of them don't have the start capacitor and start relay. There's probably a couple of them around here that do have that.
Right there, the one I was telling you who was teaching me. It's right there.
Yeah. Okay.
You got 2 of them on the run and the start capacitor.
Okay. So that one uses start assist, this one doesn't.
You got a heat pump on it too.
Mm-hmm. So, you know, and as far as this, everything in here, there's a wiring diagram glued to the inside of the cover panel. It is black lines on white paper, which we're going to be talking about and going over. It's going to tell you where every wire in here is supposed to go. So it's like you've got a cheat sheet of all the controls on this paperwork. It's like you've got a cheat sheet right here that tells you what to do. Right? But you have to learn how to read and interpret the cheat sheet. Okay, there's kind of a code to it. How to learn to read it. So when you go out to work on a unit, you ain't got to guess where all the wires are supposed to go. You got a panel, a cover that tells you all the where the wires are supposed to hook up. And it even breaks down and tells you most of the time what color wire you're looking at. we're looking for. So you notice there's a purple and browns and yellow and reds and all that. It's going to tell you on here what color wire probably is. Okay? Does not mean they're all exactly the same in every unit. Different units, different colors a lot of times. But it's going to tell you on the diagram for that unit what it's supposed to be. So when you're looking for these wires, you say, well, on here it says it's supposed to be a red wire. So if I'm looking for a red wire, I'm probably going to pick this one out, right? I ain't going to be looking at this yellow and this brown and all that, right? The color coding, the color association helps you find the right wires, okay? But you cannot still live and die by wire colors. It's an aid, but it is not it's not the foolproof way of doing things, right? You don't know if somebody changed out the wire and they didn't use the same color. They used a different color wire. So it may not jive with the diagram says. You got to figure this stuff out. The process of elimination somehow, okay? But anyway, let's put this cover back on. At the operator coil section, and this was a gas furnace with the blowers underneath typically. The burners and everything is all up in here for the gas heater, okay? Good question. If the plastic drain pan was to develop a crack in it where it's leaking water, yes, you can replace the drain pan. Now it entails pulling the whole coil section out to get it out of the way so you can change the pan out, right? It's a pain in the butt, but it can be done. If the coil pan, now that's kind of rare, you don't see it that often where the drain pan develop cracks, but it has happened, okay?
Bacteria buildup.
Oh yeah. What I'm going to say is, right there where the line connects into the drain pan is a very common place where it gets stopped up. So the pan is filling up with water, but it can't leave through the drain line because the opening is stopped up. Due to bacteria growth, mold growth, crud, dust floating in the air settles in the drain, and it clogs up the drain, just like it clogs up the drain on your sink. And then you got to get in there, take the panels off, and access it to clean it out.
Good thing you use evaporated. So that bacteria like getting your airflow.
That's the indoor blower motor, yeah.
Indoor blower motor. Evaporator coil.
Right.
What they say right here up in here?
The burner section of the heater, it's a gas furnace.
Gas furnace.
So they basically like what you were saying, where the wires that loop together.
Steel water leaks are live.
So we gotta know a little about that plumbing. Yeah.
Y'all know something about how the drain system works and how it ties into the plumbing system and all. And you got to be able to clear it out, clean it out. You don't carry probably, anybody know what a wet vacuum?